Good morning, guys. Today we are going to discuss about circular linked list. In the last class, we have discussed about doubly linked list. Now we are going to discuss about the other important variant of linked list, that is circular linked list. So, uh, what is a circular linked list and what are its uses and how you add or delete a node in a circular linked list? That is what we are going to discuss here. See, all elements of a linked list can be accessed by setting up a pointer pointing to the first node of the list and then traversing the entire list. So, in order to move or check some move on to a particular node in a list, the first thing or the first step that you have to take is to um, find out the pointer pointed to the first node of the list, and then you can traverse the entire list. But it has some drawbacks. So what are they? Say, given a pointer current to the node SLL, we cannot reach any of the nodes that precede the current node. So if I say this is the current node, this is the current node. If I'm pointing to the current node, then I can read only the nodes which are after the current node, nodes which are not before the current node, because a single circular list travels only in one direction. But this drawback can be overcome in DLL at the same time with the help of SLL, circular list, circular linked list. So in DLL, we have to maintain two links, one which points to the forward and one which points to the backward, or one which points to the successor and one which points to the predecessor. So how you can implement the same in circular? So this drawback can be overcome by making a small change and without any additional data structure. So what is it? The last node of the links field is set to null. Link field of the last node in the list is actually set to null. Instead of that, store the address of the first node of the list in that link. So you will be storing what? The address of the first node. Till now, this last link field of this last node was set to null. Now you will be pointing this link, or you will be storing the address of the first node as the link in this last node. So this forms what circular linked list. This change will make the last node point to the first node of the list. So automatically it forms a circular linked list. So for any node in such a list, it is possible to reach any other node in the list. Yes. So for any node, um, from any node, so for example, from R, I want to reach to P, then no, if it is in general, it is a linked list without the circular option. So what happens? You will be ending here, you can't reach P, or you have to first find out the pointer of this list, and then from there again you have to traverse. But if you are using a circular linked list, with the help from this node, you will reach the last node, and once you reach the last node, again you will be going to the first node. From there you can go to this node. So we need not traverse the list again right from the first node. Okay, so I mean, you from this part of the node you will be traversing, but no need to come out of the list and find out the pointer and then again enter the list and find out your node. You will be moving from the last node to the first node, as the last node link points to the first node, and you can go to the node or find out the node whichever you want in this list. So circular linked list is used in many applications. So what are the applications? See, it is used to keep track of free space, unused nodes in memory. So the main purpose or use of circular linked list is keeping track of the unused nodes so that it can notify where the free space is available. And in a circular linked list, traversal can be continued from current node. So always there is no need to start from the head. You can start your traversal from here also, from here also, from even from the last node because the last node points to the first node. It helps us to keep traversal procedure an unending one. So there is no end until and unless you come out of it. So you can do so many operations by revolving in this list only until and unless you come out of the list. The two primary applications of circular list are time slicing and memory management. Already we have seen circular list is used to keep track of free space, so it comes under memory management and time slicing. So how to allot the time to various tasks in general. This comes with your operating system. This term comes with your operating system. So how to allocate time to different processors and all these can be maintained by this circular linked list. So again in circular linked list we have two variants that are a circular SLL and circular DLL. I mean both single linked list as circular list, double linked list as a circular list. And next, with and without header nodes. Yes, we have seen these are in double linked list also with header node and without header node. So we can see the same variations in circular linked list also. So how a circular linked list is represented. This is how a circular linked list is represented. The head is pointing to the first node in the list and the link of the last node is pointing to the address of the first node in the list. See, in a singular circle list, the pointer head points to the first node of the list. From the last node, we can access the first node. So when we go on to the last node, we can automatically access the first node. But we cannot access the last node through the header node because we are pointing the head to the first node of the list, that is the header node of the list. So you can't find out the header node if there is a separate node called header node which is pointing to the first node of the list, then you can't find out that through the last node. So the drawback here is to reach the last node of the list, we have to traverse the whole list. So instead of head pointing to the first node of the list, we will be setting it so that it points to the last node of the list. So because the last node automatically points to the first node of the list, you can get the first node and the header points to the last node of the list. So if you want the last node, if you go to the header, automatically you can get the last node of the list. So the head, now through head we can have access to the last node and it also gives us the address of the first node. So head next what it points to the first node of the list. Next, circular list with header node. So this is a singly circular list. So circular list with a header node. Uh, how if you have only one node in the list, so what happens? Singly circular list only with two nodes, one being the header node. So this list points to this list and this list points to this list. So it becomes like a loop kind of thing. Circular list with single node has a problem of checking end of traversal. So where to end? So where is the end of this list? That becomes a problem. So this can enter into an infinite loop. So to overcome this, so what we are doing here is we are inserting a, in this list we have just used the head point. We are not using any header node in separate. This here we are creating the circular linked list with extra header node. So this is your header node. You can find out that this is a header node by looking at the data. This is having some numerical data and this is having some alphabetical data. That means this is the header node which is showing the number of nodes in this list. So already we have discussed what a header node is, which contains some special information like number of nodes, the type of node, all these things. So if this circular list with header node can be represented in two ways. So this is how it looks like, and this is how it looks like in the other form. So suppose if we want to insert a new node in the front of the list. So what happens here? The first thing is change the link field of the last node. Yes, because the last node is pointing to the first node of the list. That's what a circular list is. So if you are inserting a new node at the front of the list, so the link field of the last node should also change. Yes. So in addition, we have to traverse the whole list to reach to the last node, as the link field of the last node is also to be updated. So here, what happens if the head is pointing to the starting or the first node of the list to reach the last node, because we have to update the last node uh, as we are updating the first node to a new node, and we are inserting a new node in the starting position. So as the last node link will point to the first node link, you have to update the link field of the last node. So you have to move to the last node, you have to traverse the whole list to reach to the last node, so as to update. So we it is said that it is convenient to set the head point to the last node rather than the header node, which is the first node of the list. So the head pointer, instead of pointing it to the header node, that is something but the first node in your list. If we make the head pointer point to the last node of the list, then it will be easy, or it reduces this uh, uh, the need to travel to the last node to update it when you are inserting a new node at the front position. See, now this is the header node. Actually, this is a little bit wrong. So this is your header node, and this is your last node where your head pointer is pointing the last node, which makes the insertion at the front as well as the end easy. So this reduces the traversal to the last node when you want to insert a node in the front end of the list. Next, doubly circular linked list. So this is a singly circular linked list, doubly circular linked list, how it looks like this. In a doubly circular linked list, the last node's next link is set to the first node of the list, and the first node's previous link is set to the last node of the list. That is what, see, this is your first node. This will actually, in a node, this will point to the predecessor, and this will point to the successor. So in the first node, this link, I mean, the actually it is empty because if it is a single linked list, but if this is a circular linked list, so the link or predecessor link of the first node should point to the last, okay, because it has to reach, because it can be left empty in double circular list. And the successor link of the last node will point to the uh, first node of the list. This is common. Actually, this part is common. The last node, the link field of the last node, successor link field of the last node will point to the first node. That is common. But the thing is, the link field, predecessor link field, because here you have two link fields, one for the successor and one for the predecessor. Generally, this is left empty or it is set to null. Instead of setting it to null, this is set to the last node. So what happens, instead of setting this head to the last node, this will directly give access to the last node from the first. This is the advantage of your doubly linked list. This is how it looks like. If you have a header is different, head is a pointer, header node is different. So if you have a header node, this is how it looks like. So header node may store some relevant information to the list. So again, see here, the first, yeah, header node, uh, first, I mean, predecessor link is pointing to the last node and the last node's successor link is pointing to the first. So this is how it is represented. This and this are the same. The thing is here an extra header node is added. The same operations, whatever you perform on a circular list, a linear list can be performed on a circular list like insert, delete, create, and traverses, but with few changes because you will be always pointing to the you will always point or you have to set the point last node to the first node. Always make that last node of the list point to the first node of the list. That is what is the main thing that you have to keep in mind when you are implementing a circular linked list, whether it is a singly circular linked list or doubly circular linked list. So this is about your circular linked list with what is a circular linked list and the different variations with it. Singly circular linked list and doubly circular linked list with header node and without header node. So this is your class. If you have any doubts, ping me.